Hey, what's up? This is Malia with OSU ESRA Rocket Team, and today I have something really exciting to show you. This is FarmBot. FarmBot is our payload that'll go inside of our ESRA rocket up to 30,000 feet. On the way down, it'll be ejected at 1,500 feet with its own parachute. Now, once it lands, it's going to disperse, it's going to water, and it's going to monitor a set of seeds. Now, let's go see how the rest of the team's doing. Hey, Michael, what you working on?
Hey, what's up, Malia? I'm actually just painting the payload. Just like these 3 blocks, it's made up of 3 sections. As you can see, the first section is the disperser section. This will hold the disperser and the motor. It'll spin and send out seeds around it. The next section is the electronics bay. This will house the computers, sensors, and make it run. The last one is the water tank. This will store the water and pump water to the disperser.
That's very cool.
By the way, what's Nick going on with the parachute?
That's a great question. Let's go ask him. Oh, hey, what's Nick doing up there? Hey, Nick, how's the parachute going?
Hey, I'm working on the parachute for the payload. Our payload's unique because it separates from the main body tube. It's going to be separating alongside the main body at 1,500 feet. Both the payload and the main body of the rocket are going to have their own parachute, and the payload itself is going to help rip out the main parachute for landing.
That's really awesome. Thanks for showing us. Let's go see what Ben's up to.
Hi.
Hey, Ben, how's machining going?
Hey, it's going fine. Just making up the arms for the test stand so that we can test our various disperser concepts. So our payload's going to be undergoing a lot of forces during the launch with our rocket and everything. So we got to choose our materials and refine the geometries of everything and go through all the testing to really make sure it's going to survive that launch. So all of our components are made out of 6061 aluminum with a couple made out of 3003. And the panels on the side of the payload are made out of fiberglass to protect everything inside, and then also allow all the electronics inside to transmit just fine. So anyways, that's what I'm doing right now, is making that test stand so we can test things.
Speaking of payload, what's a CubeSat?
That is our payload, and that's a CubeSat format. CubeSat format models after a 10 by 10 by 10 cube, which is used for a satellite. This is a 3U, which is 3 of those stacked together. So it's a 10 by 10 by 30 centimeter. And it's commonly used by NASA and by SpaceX for a lot of the satellites, the GPS satellites and stuff like that they put into space.
All right, thanks for explaining that, Ben.
No problem.
Hey guys, it's Malia again, and now I get to show you the coolest part of our payload, the circuitry. So here we have a slightly more assembled payload, and I'm just going to show you the parts. We have a breadboard for all of our connections. We have this CO2 temperature and humidity sensor to get data about the environment. Everything in this payload is controlled by an Arduino Nano. Down here we have the pump. If you come over to this side, we have an SD card, which is going to store all the data that we collect. We have the motor down below our disperser. And before launch, we're going to make sure that we turn on these switches, which will start power to the entire circuit. All the power is going to be provided by 3 LiPo batteries in series. And then we have this really cool piece of technology called a Telemega, which is going to be our flight computer and is going to signal to the Arduino Nano when we have landed to begin all of its processes. Hey, I think I see Colin. Well, let's go see what he's up to. Hey Colin, you got my code?
Oh, hey Malia. I'm just adding the finishing touches to the payload software. The software uses C++ and Arduino architecture to give instructions to the payload circuit. So, once the payload begins operations, the servo will activate and extend the orientation arm doors to adjust the robot's position. Then the pump activates to flood the disperser with water, which is followed by the activation of the motor to spin the disperser and eject the seeds and water from the robot. the Arduino also communicates with our onboard sensors, retrieving data from the environment such as temperature and humidity. All of that data is stored onto an SD card using an SD card reader. So that's how the software works.
So there you have it, guys. Our 2022 payload, FarmBot. Ciao!